Hello and welcome to a new episode of Mancave Printing. In today's episode I want to test out optimizing software for your Cura printing profile. The software is called 3D Optimizer and is used in your browser. I got a code to test it 2 weeks for free. The code is from website Redline-Filament. And the code is RF-Redline, so you can also test it for 2 weeks. In here we can start a new guided testing session. So recently I got some cheap Chinese filament, not much left on the spool, but perfect to test if we can optimize our Cura profile for this filament. To compare this to my normal filament, I will first print out the Banshee with my normal PLA settings. And after that, I want to test again if we do any better with printing out another Banshee, and then we can compare my two profiles. And if this works good, I will do it with all my other printing profiles like PETG. So first we give our session a name, so PLA China seems pretty good. Our target is, I would say, mechanical strength. We want the guided one, and our 3D printer is an Creality Ender 5. Our material is normal orange China filament. As you can see, I tested it out before. So I get my recently done names and materials. So build plate I use is glass. And now we can start a testing session. So as you can see here, we got a quick guide for every test we get. There are, I think, 15 different tests you can do to optimize your Cura profile, but I think we do not have to do all these. We have to enter some values we want to test. So we have to enter the first layer track height, first layer printing speed, our bed temperature we need for our material, the first layer extrusion temperature, and our first layer track width. So I want to test the first layer height from 0.1 millimeter to 0.25 millimeter. The printing speed I want to test is from 10 to 30 millimeters, like it is set down beneath here. My print bed temperature for PLA is normally 65 degrees Celsius. Our first layer extrusion temperature is 210 degrees Celsius. The track width is the 0.4 millimeters my inner nozzle diameter is, and I do not have to do an extra set offset. So the 3D optimizer is configuring a G-code. We upload it into our Octoprint, and after that we can print it out. So let's put on download and print it out. After we printed out the file, we have to inspect the printed test structure and then check all these questions. So I will show you a picture of the first test print. And so the print didn't float above the print bed, so no. The print didn't peel off the bed, also no. there are no voids between the track, and also the nozzle isn't too close to the print bed. So I couldn't get the print of the bed in one piece, so I did a photo on the print bed, and I think 0.17 millimeters and 23 millimeters per second are the best choice here. So we are right in the middle. Let's check this box and go to the next test. Regarding to your previous answers, you will get guided to the next test that is necessary. So in this example, we do not need to do test 2. We get directly to test 3. So now we want to test the extrusion temperature. I think I will test from 200 to 215 degrees Celsius, and also the printing speed. I'll take the 30 to 70 millimeters per second, so 30, 70. Part cooling for PLA, because of my Hydra fan duct, we don't need 100%. I think 32 are enough. So Extrusion Multiplier stays 1. The track height we want to print is 0.2, which is okay for normal quality, I think, and track width stays at 0.4. We download the G-code and upload it and print it out. So now that we've printed out the third test, we can check these questions. Also no voids. I'm pretty satisfied with the result. So now we will select the best parameters, and I think the best parameters here are, it's hard to say, they are all pretty the same. So I think we go a bit slower and also the temperature a bit down. So I think we will take 208 degrees Celsius and 43 millimeters per second. So let's go to the next test. I will also do a circle around every result I've selected so that you can easily find it. I think on the pictures it's hard to tell any difference, so you will know what I chose. So the retraction distance is the next test. As you can see, we go straight to test 10, so seems to go pretty good for me. So 200 is definitely way too much. I think with my bound setup I don't need any more than like 15, maybe a bit more, but I will do as less as I can go. So we go from like 6 to 15. So, and the retraction speed we start with is 45 millimeters per second. Also download the G-code, let's print it out. So the retraction test comes out, and here's a picture of it. As you can see, none of the test results is good. I think we got all these little blobs and stringing between the two printed lines or printed blocks. So are all the tested values bad? I would say yes. But if you ask which one is the best, I would definitely say the third one from the right, because there are less blobs between the two tracks than any other. So we will go with 9 millimeters. So let's go on to the next test. This is test 8, the extrusion temperature. So I think, I don't know why these values are so different. from logical temperatures, like who prints at 6 degrees Celsius or 15 degrees Celsius? That's not even possible. So let's say like 200 to 215. As you can see, this test is optional. So because my answer to the question if all examples were bad, we get to an optional test to get better results. Also, we need to set the retract distance, so I think we go a bit higher because no result was good. So let's go from like 14 to 20. And also the retraction speed, I think we will go from 45 to like 90 and download the G-code. It looks like we have no real favorite. They are all not that great, but I think we have to use one. So let's see what we can do now. I really don't like any of these, so I think all combinations are bad. And we go to the next test. So now we get to test 9, where we test the retraction distance, the printing speed, and retraction speed. So this seems pretty like the last one we did, but so far so good. We need the retraction distance. So we go from like the last time 14 to 20. Printing speed, we go from 25, no, we go from 30 to 70 like the last time, and the retraction speed. We also do this again. So let's see what we get here. Here we could say the best combination looks like this, I think. And so we go on to the next test. So we get to test 10, the retraction distance. Okay, so we get this a second time. So let's see if we can get any better here. So let's say retraction distance. We do a high range from 8 to 20. Let's do it like this. So this time not all tested values are bad. I would say my favorite is, it's hard to tell. Even though there are some little blobs, I would say my favorite is 12 millimeters, or we will go with 14 just to be safe. So next, the bridging test. Okay, this looks interesting. So let's see what this tells us. So bridging extrusion multiplier. Okay, I don't have an idea why these values are so big. So the multiplier says how much more filament you press through your nozzle. So this would mean you press 8 times as much as filament as you need. So like flow rate of 800%, I think, and this would be 2000. I think that's not right. We will test from 0.5 to like 1.5. So we do 50% flow rate to 150% flow rate, and also the bridging speed. So we do not have the flexible materials, we have harder materials, so we do 15 to 35. So it recommends 15 to 35, but does something like 70 here, so I don't know. So bridge part cooling we will do like 50%, download the G-code. So, and here's the example. So I think the best is with like 1.5, so 150% flow, and source one test I like more. This is this one. This looks pretty good. Maybe needs some fine tuning after, but I'm happy with that. So to the next test. There's no next test. So okay, we got slicing profiles we could download. So, or we can look at the test report. So let's see. So it seems like it ignores the one test we did twice. Yeah, I can't find any test twice. So here we see all our selected values, and here we see also our other selected values like print width temperature, extrusion, first layer temperature, part cooling, height, extrusion multiplier, retraction speed, critical overhang angle. Okay, this is cool. You can see here how many filament you consumed, and also the estimated printing time. So the big advantage of this test or like this optimizing program is that you don't need much filament, like 5 meters is like nothing. But I think I've wasted more than 5 meters because I had to do 1 or 2 prints again because they did not stick to the bed. But that's still okay, it's not much. Think about printing some temperature towers and such things, they take more than 5 meters, I think. Also, the estimated printing time of 2 hours is okay. As I said, I had to do some prints again, so this might be a bit more. I did this after work, so I needed like 2 days, so 2 evenings or afternoons, and I am done with this. So these are only a few values, so I will put them in my Cura, make an extra profile and print out a Banshee, and after that we will compare the Banshees and see if we got any better printing results than with my normal PLA profile.
So there's not much to say to the two Banshees in comparison. I think the overall print quality stayed pretty much the same, but I can say with the optimized software we got more stringing. That's not good, but also not bad. And the rest of the print also looks pretty much the same, only that we got more stringing. There are no differences. In this video I want to talk about some pros and cons of the program 3D Optimizer. So let's start with the pros. I think it's good for beginners with only a little knowledge about 3D printing because it guides you through this process. Another positive thing is that it only needs a very few amount of filament and it's pretty fast compared to standard tests like temperature towers or bridging tests. They take much longer and more filament. But on the other hand, I have to say it did not improve my existing profile. I don't know if it would work better with the advanced mode, but that's not covered in this video. I think people with knowledge about the printing process can achieve the same, with just observing problems and changing corresponding values in their print settings. And the last thing that might be not that good for many people is that it costs money. You can see it right here, how much it will cost if you want to try it, but as long as the coupon is valid, you can use it for free. So the last thing is my recommendation for who it is good for. I think the software is good for 3D printing beginners to get their profiles set up, or also for people who get new materials they want to print and do not have any clue how to print and what settings are good for this material. Thank you for watching my video, and if you liked what you've seen in this video or in any other, I would be happy if you subscribe to my channel or like my videos. Thank you and see you next time. Bye.